Hi, second graders. Mrs. Joe here. I'm here with another math lesson. Today we're working on Module 6, Lesson 19, and we're going to be exploring another way that we can identify even numbers. Let me go ahead and share with you today's objective. Where's my cursor? There it is. And share. Okay. Please read our objective with me. Math objective. I can identify an even number by recognizing patterns in the ones place. All right, so today we're going to be working on identifying patterns in the one place, and that's going to help us see whether or not a number is even or odd. Okay. So right here, I've written out the numbers 0 to 15. And I'm going to be using my counters to help us pair objects. That was one way we explored identifying even numbers. If each object has a pair or a partner, then it's even. Another way we had identified even numbers was seeing if it was the sum of a doubles fact. So let's look at the number 0. For the number 0, we wouldn't put any counters down because 0 means nothing. So let's go to number 1. For number 1, we'll put 1 counter down. Does 1 have a partner? No, so it's not an even number. Let's go to number 2. We would have 1, 2 counters. I just made a column of 2. Look, each counter has a partner. It's a pair. We also could think of this as a doubles fact. What would the addition sentence be for this doubles fact? 1 plus 1 equals 2. So we have just shown that 2 is an even number. Let's circle the number 2, okay? If we go to the number 3, we have 1, 2, 3 counters. These guys have a partner, but this guy does not have a partner. So 3 must not be even. It must be odd. Let's underline our odd numbers. We also had said that 1 was odd. Okay, let's go to 4. Right now we have 1, 2, 3. Now we have 4. So we have a partnership here. They're paired together. We have a partnership here. There also would be a doubles fact sentence for this number. Can anyone think of what the doubles fact sentence would be? That's right. It would be 2 plus 2 is 4. So we just proved that 4 is an even number. Let's go to number 5. We have 1, 2, 3, 4, 5. These guys have a partner. These guys have a partner. Oh, but he does not have a partner. So it looks like number 5 is not an even number. It is odd. Let's go to number 6. 1, 2, 3, 4, 5, 6. Ooh, here's a pair. Here's a pair. Here's a pair. So everybody has a partner. Also, there's a doubles fact for this number. Can anyone think of what the doubles fact number is? That's right. It's 3 plus 3 is 6. Also, we can count by twos. We also talked about counting by twos yesterday. 2, 4, 6. We just proved that 6 is an even number. We're going to try 7. We have 6, 7. Oh, this guy doesn't have a partner. He must not be even. He must be odd. Now let's go to 8. We have 7, 8. So now we have partnership here, partnership here. These have a pair. This is a pair. So everyone has a pair. Also, there is a doubles fact here. Anyone know what the doubles fact is? That's right. It's 4 plus 4 equals 8. So we have a doubles fact as well. Let's try counting by twos. 2, 4, 6, 8. Wow, we just proved really well that 8 is an even number. Everybody had a pair or a partner. We could count by twos, and it's a doubles fact. So we have 8 counters. Let's try 9. Most of them have a partner, but this guy does not. 9 must be odd, not even. So we have 9 counters right now. Here's 10. Again, everybody has a partner. So we were able to pair up our counters. Also, there's a doubles fact. 5 plus 5 is 10. Also, we could have counted by twos. 2, 4, 6, 8, 10. So we're going to circle 10 because it is an even number. We just proved it. Let's go to 11 by adding one more counter. Oh, I can tell just by looking at this, he doesn't have a partner. So 11 is not even, it must be odd. Let's underline that. All right, moving on to number 12. We have 12 counters here now. Again, we have everyone with a partner or a pair. There's no counter left out by itself. And we have a doubles fact. 6 plus 6 is 12. We also could count by twos. 2, 4, 6, 8, 10, 12. So 12 must be an even number. Let's circle it. Let's try 13. We had 12, now we have 13. Oh, 13 is left out all by itself. So again, when we have an odd one left out, it's an odd number. We have 13 counters right now. Let's add one more to get 14. All right, everyone looks like they have a pair. There's a partnership happening with each counter. Nobody's left out. We also could do a doubles fact by saying 7 plus 7 is 14. We also can count by twos. 2, 4, 6, 8, 10, 12, 14. All right, we just proved that 14 is an even number because we saw that each counter had a partner or a pair. We saw that it was a doubles fact, and we could count by twos. Let's try our last number, 15. Oh, I can tell just by looking that this guy does not have a partner, which means that 15 is odd. There's an odd one out, so we're gonna underline there. All right, looking at our pattern of what we have here, let's see. It looks like every other number looks like 1 was odd, 2 was even, 3 was odd, 4 was even, 5 was odd, 6 even, 7 odd, 8 even, 9 odd, 10 even, 11 odd, 12 even, 13 odd, 14 even, 15 odd. So we just found a pattern that every other number is odd or every other number is even. That's very interesting. There's another pattern that I see here when we look at our ones place. Let's look at our ones place for a number that's even. Look, 2 is in 1, 2 was even. Let's skip all the way down to 12. In the ones place, there's a 2, and 12 was even. Let's look at 14 and 4. 4 was even, and 4 was in the ones place. Look at 14. 4 is in the ones place, and 14 is even. Let's look at some odd numbers. 1 is odd. Let's look at 11. There's a 1 in the ones place, and 11 is odd. Let's look at 3. 3 is in the ones place, and that's an odd number. Look at 13. 3 is in the ones place, and that's an odd number. So we're seeing a pattern when we look at the ones place. This is the pattern. Let's get the same colors we used before. All of our odd numbers are underlined. All of our odd numbers are pink. We saw that when a 1 is in the ones place, it's odd. When a 3 is in the ones place, let me write that a little lower so everyone can see better. It's odd. We saw that when a 5 is in the ones place, it's odd. And when a 7 is in the ones place, it's odd. And when a 9 is in the ones place, it's odd. All of these were odd numbers. Also, if we look at our even numbers, the ones in this kind of blue-purple color, we saw when it was a 2 in the ones place, it's even. When it's a 4 in the ones place, it's even. When it's a 6 in the ones place, it's even. When it's a 8 in the ones place, it's even. And also, when it's a 0 in the ones place, it's even. So whenever we see a 0, 2, 4, 6, or 8 in the ones place, it is even. All right, now that we've found that pattern together of every other number being even and every single number that has a 0, 2, 4, 6, or 8 in the ones place is even, it's time to try your problem set on your own. Remember, today you're working on Problem Set Module 6, Lesson 19. As usual, if you have any questions, reach out to your teacher. Bye, second graders.